In this tutorial, we're going to focus on graphing piecewise functions. So let's start with this particular example. F of x is equal to x when x is less than 0, and it's equal to 5 when x is equal to or greater than 0. Now let's graph these two functions separately so we can get an idea of what they look like. So the graph f of x equals x, or y equals x, is basically a straight line with a slope of 1. So it rises at a 45-degree angle. So that's y equals x. Now the second graph, f of x equals 5, or y equals 5, it looks like this. It's a horizontal line at 5. Now, we only need this portion of the graph when x is less than 0. And we need this portion of the graph when x is greater than or equal to 0. So the piecewise function is going to combine the left side of this graph with the right side of that graph. So let's put it all together. So when x is less than 0, but not including 0, we're going to have the graph y equals x. So I'm going to put an open circle at 0 because it does include 0, but it's going to look like y equals x on the left side. Now on the right side, it looks like y equals 5, but it includes 0. So I'm going to use a closed circle at 5. So keep in mind the y value there is 5. And that's how you can graph this particular piecewise function. Let's work on another example. So let's say that f of x is equal to 2 when x is less than 1, and it's equal to x plus 3 when x is greater than 2. So feel free to pause the video and try this example. So it's equal to 2 when x is greater than 1. When x is less than 1, I take that back. And it doesn't include 1 itself. It's less than 1, not equal to 1. So we're going to have an open circle at 1, 2. And because it's just a constant, it's going to be a horizontal line, but less than 1, so we got to graph it to the left. Now at 2, we're going to have the graph x plus 3. Now this particular graph has a y-intercept of 3, and it has a slope of 1. So it has these points. So when x is 2, this graph is going to be at 5. So it's going to be up here already, and then it's just going to increase at a 45-degree angle with a slope of 1. So I'm running out of space, but this is how the graph is going to look like if we take this part out. So this has a y value of 5. We don't have any enclosed circles in this example because there's no underline with the inequality. It's just x is less than 1 or greater than 2. Here's another example. Let's say that f of x is equal to 2x plus 1 when x is less than 1. And it's equal to 1 when x is equal to 1. And it has a value of negative x squared when x is greater than 1. So let's start with this. So when x is 1, if we plug in 1 into this expression, that's going to be 2 times 1 plus 1. So that's going to give us the point 1, 3. And that's going to be an open circle because it doesn't include 1. Now this graph, it has a slope of 2 and a y-intercept of 1. Keep in mind, it's a linear equation in the form y equals mx plus b. So the number in front of x is the slope, and this number is the y-intercept. So we also have this point when x is 0, y is 1. So we can say this graph looks like this. We can only plot the left side of the graph, where x is less than 1. Now here, when x equals 1, y is 1. So that's just a point. We don't have a straight line. There's no range of x values. It's just one single x value. So we got the point 1, 1. So when x is 1, y is 1. So this is going to be a closed circle right here. Now when x is greater than 1, we have the graph negative x squared. Positive x squared looks like this. It's a parabola that opens upward. Now what do you think negative x squared looks like? This is a parabola that opens downward. So if we plug in a 1 into this expression, that's going to give us negative 1. So it's going to have a point in this region, but we're going to use an open circle because this doesn't include 1. Now when x is 2, this will be negative 2 squared, which will be negative 4. And that should be somewhere down here. So it's going to look something like this. We need to give it a curved shape. It won't be a straight line. And so that's the general shape of this particular piecewise function. As long as you take your time, graph it step by step, you should be fine. It's not that difficult. But let's work on some more examples. So let's say that f of x is 3x plus 4 when x is less than 0. It's equal to 2 when x is equal to 0. And then it's equal to the square root of x when x is greater than 1. So go ahead and take a minute and try that. So let's start with this. So once again, we have a linear equation, y is equal to mx plus b. M is 3, and b is 4. So the y-intercept is 4. When x is 0, y is 4. So we're going to have an open circle at 0, 4. Now we can only graph the left side of that function. So if we plot the point x equals negative 1, the y value will be 1. 3 times negative 1 plus 4, that's negative 3 plus 4, so that's 1. So we got the point negative 1, 1. Also, you could use the slope. The slope is 3. So if you go backwards, you need to go 1 unit to the left, down 3. That'll give you the point 1, 1. So this graph looks like this. When plotting a linear equation or linear function, you only need 2 points to graph it and then connect it with a straight line. Now let's focus on the next part. So when x is 0, y is 2. So we got the point 0, 2. And that's going to be a closed circle. Let me put that in red. And then when x is greater than 1, we have the square root of x. So if we plug in 1 into the square root of x function, the square root of 1 is 1. So we got the point 1, 1, but we need to use an open circle. It doesn't include 1. And then the next point I would plug in to this expression is 4, because the square root of 4 is 2. So that will give us the point 4, 2. And so the square root function looks like that. It's an increasing function that increases at a decreasing rate. It increases slowly. And so this is the piecewise function that we have for this particular example. Now let's try one last example. So let's say that f of x is 1 over x when x is less than 0. It's equal to 3 when x is between 0 and 3. And it's equal to negative x plus 5 when x is equal to or greater than 3. So 1 over x looks like this. It's negative on the left side, but positive on the right side. So that's the graph of 1 over x. Now we only need the portion where x is less than 0, so we only need that portion of the graph. So let's get rid of this stuff on the right. Now, between 0 and 3, the y value will be equal to 3. So it includes x equals 0. We're going to have a closed circle here, but it doesn't include x equals 3. So I'm going to put an open circle at this point. So it's a straight line at 3, at a y value of 3. Now when x is equal to or greater than 3, we have negative x plus 5. So if we plug in 3 into that expression, it's going to be negative 3 plus 5, which is 2. So we're going to have a closed circle at 3, 2. Now the next point, if we plug in 4, negative 4 plus 5 is 1. And we can see why it's going down because it has a slope of negative 1. If we plug in 5, negative 5 plus 5 will be 0. So that will be the x-intercept of this piecewise function. And so we can see it's going down like that. And so that's it for this example.